The next step in my feasibility design process is to start looking at the terrain and trying to work out possible routes through this area. First, I will create a set of triangles. So it's surface, triangulate surface, from the digital terrain model, create triangles. And that has created 128,000 triangles. Now I want to see those triangles displayed on the screen. Surface, View, Triangles. And here are those 128,000 triangles. If I zoom in, you can start to see some of the detail here. The first analysis I want to perform is to create a set of contours. The purpose of this is twofold. I want to be able to check for rogue levels, and I also want to be able to get a feel for the shape of the terrain. I'm going to create contours at 10-meter intervals with major contours at 50-meter intervals. And here, as I zoom in, again you can see the contours overlaid on top of the triangulation. Contour annotation is provided at every major contour. The triangulation that you have created can also be subject to further analyses for aspect, elevation and slope. Color coding by aspect allows you to apply colors to the triangulation according to the direction that the triangles are facing in. Typically these are north, east, south and west. From an engineering perspective, the aspect is important. For example, in some countries, north-facing slopes might be subject to snow and ice. A south-facing slope might be subject to high heat gain, so these would be areas where you avoid cuttings which may increase the heat and temperature on the rail, which potentially could lead to buckling of the track. Now when I zoom in, I have north-facing slopes shown in blue, east-facing slopes shown in green, south-facing slopes shown in red, and west-facing slopes shown in brown. So it's very easy for me to identify the directions of each of the slopes. Now I want to look at color coding by elevation. This gives me a very quick and easy way to identify the level bands across my digital terrain model. If I look at the color table, the system has automatically split the elevation color coding into bands according to the level from the lowest level in the DTM to the highest level in the DTM. Put on the position where you want the legend, and it is now processing. When I zoom in, now you start to see some of the banding. So here I can see that I will be primarily following a level path if I go along through this area, but as soon as I start going up across the bands, of course the gradients get much steeper. Over in this area, where I'm looking at route options, I can start to identify where the banding shows me where I can potentially put short tunnels in, for example through here, or an alternative route might be to tunnel directly under here through the highest part of this mountain. The final analysis I want to perform is color coding of triangle slopes. This will show me where I have sidelong ground, which is likely to be difficult for construction of the railway. For the purposes of my analysis, I have split the slopes up into different gradients. So if I apply that, put on the position for the legend, it will now go off and process the analysis and show me the different slopes. If I zoom in on the slopes, gentle slopes are shown in green, going through yellow, blue, red, purple, and eventually through to white. So here I can see that generally speaking the railway passing through gentle terrain, but when I look at the hilly area, the blue areas indicate slopes that should be avoided for the railway, as these will be difficult to construct on. And that completes the DTM analysis activities.